Hello, my name is Benjamin Dietzeler. This is my acceptance test for the Codesys-based structured text program with visualization. The purpose of this test is to verify that two Boolean switch inputs control one Boolean light output using exclusive OR logic, also known as XOR. The intended functionality is that the light turns on only when the two switches are in opposite states and turns off when both switches match. This creates a practical two-switch control behavior, where flipping either switch changes whether the switches match or differ, and that change toggles the light. In structured text, the program uses an if statement that checks for two valid conditions that should turn the light on. Condition A is switch 1 is true and switch 2 is false, or vice versa, meaning switch 1 is false and switch 2 is true. If either of these conditions is true, the program sets light 1 to equal true. Otherwise, it sets light 1 to false. This is the definition of a XOR logic. The output is only true when the inputs are different. To begin, I currently have the Codesys project open with the structured text program loaded and the visualization screen visible. The visualization provides two input switches labeled for switch 1 and switch 2, and an indicator output for light 1. I will run the program in a simulation or online mode so the changes in the visualization inputs are processed by the PLC logic and immediately reflected in the light output. The first test case would be both switches are off, meaning the light is off. This is the expected result because the switches are in the same state, so the XOR logic evaluates to false. So the program should be set this way. Next, I toggle switch 1 to on while keeping switch 2 off, meaning that they are now in opposite states. The expected result of this is that the light turns on. This can be confirmed by seeing that when the switch is flipped, the state of the light changes. The other case would be if switch 2 is true and switch 1 is set to false, also turning the light on. Matching the satisfied criteria of the first test case. Now, similar to the starting state, if both switches are set to on, this turns the light off. This is the expected result. The if condition is overall false, and the else branch runs setting the setting for light 1 to false. This is confirmed by the visualization. Now, overall, you can see that switching either switch 1 or 2 will affect the state of the output. But overall, if they are in opposing states of false or true, the light will be operating properly. This proves that either input changes the match versus mismatch condition and flips the output, which is exactly the XOR behavior described in the program logic. To conclude, this verifies that all four possible switch combinations through the visualization interface are confirmed, and the output behavior matches the acceptance criteria. The structured text logic correctly implements XOR control with the light on and the switches are opposite and off when the switches match. Thank you for watching.